Working in drafty rooms caused by an air conditioning system makes us feel uncomfortable. Unlike birds, we have no feathers, and, so to us, drafty air movements are unpleasant and disturbing. Precision and quest for quality. These are some of the attributes that ensure success for worldwide enterprises such as MTU Munich. Its jet engines, turbines, and transmission technology and systems have become world-famous icons of MTU. High-quality clean air in the production halls is an important requirement for the manufacturing process, as well as the staff working on the production of these high-precision components. HVAC systems face the challenge of balancing the need to supply the room with an optimal amount of fresh air to satisfy the oxygen requirement, while achieving homogeneous distribution of air temperature without creating drafts. You can see how the artificial fog is caught by the supply air and immediately sucked towards the ceiling. Using current HVAC technology, the mixing of supply air with air in this production hall can only be achieved via high supply air velocity, creating high air currents. A lot of energy is required to create these high supply air speeds. High supply air speed causes drafts and results in directed air currents. Directed air currents from the supply air vents towards the return air vents cause a portion of the supply air's temperature energy to be wasted, being sucked back out without sufficient mixing with the existing room air. High energy costs put a significant burden on the cost of the production process. Using the Bauer optimizing system, the previous pattern of directed air currents changes completely. Despite the fact that the artificial fog is now blown directly towards the ceiling, you can observe that the air currents flow in all directions and the artificial fog dissipates uniformly in all directions. With the elimination of the directed air currents, this technology provides the immediate and homogeneous mixing of the supply air with the existing room air. To demonstrate that effect more clearly and facilitate longer visibility of the artificial fog, we blow in more fog to increase its concentration. In a very short period of time, this vertically blown-in artificial fog distributes evenly and with ever-changing direction throughout the production hall. Even large production machinery becomes completely immersed in the fog and no longer forms an obstacle for evenly distributing supply air throughout the whole production hall, from floor to ceiling. Even though the return air vents are fully open when using the Bauer optimizing system, the fog is not directly sucked out of the room. This is due to the elimination of the directed air currents. This demonstrates that there are no longer short circuits between the supply and return air vents. The positioning of supply and return air vents no longer has any influence on the air distribution in the room. The improved air currents are especially visible in the ceiling area. We can observe the even fog distribution not only close to the ceiling but also towards the floor. Especially impressive is the improved airflow very close to the floor. This new airflow pattern does not even change despite the heat radiating from the lamp. In a random pattern, the fog flows vertically, horizontally and diagonally, seemingly undisturbed by the layers of warming air. Through this homogeneous mixing of the supply air with the room air, the usual temperature differential between the ceiling and the floor is drastically reduced. Conventional HVAC systems cannot accomplish this effect. MTU's production halls are impressive examples of the economic value of the Bauer optimizing system. Maintenance cost of your existing HVAC system is reduced when using the Bauer optimizing system. Additionally, the wear and tear on your HVAC hardware is reduced, thereby increasing the years of service. The construction cost of a new HVAC system is reduced significantly, as the Bauer optimizing system requires fewer hardware components. In summary, the Bauer optimizing system optimally delivers the dual goals of economy and comfort. In a conventional system, these two goals are mutually exclusive. Out of these complementary goals, we developed our company motto: the more you save, the better your room feels.